Welcome from Halifax. Yeah, I'm a first-year PhD student with Frank at Dalhousie. And today I'm going to be talking about model editing. And to set the stage a little bit, I'm going to be talking about an evaluation methodology we can use to understand the impact of model editing on long-form generation. And so when I'm talking about long form, really I'm talking about sort of paragraph length or longer generations from large language models. But what is model editing? I think since it's kind of an emerging research area, it's probably good to go over what we mean by model editing for large language models in particular, for NLP or NLG in particular. Let's maybe start with the motivation. So model editing kind of comes from this motivation where we want to directly intervene on model weights to change factual knowledge. And it's kind of at this intersection between sample and compute efficiency where we might only have one sample, or we might only have a few samples that we want to update in the model. And we want to do it in a way where there's a minimal change to the underlying model. And so when I talk about an edit or when it's talked about in the literature, usually we're talking about a natural language statement where that's representing knowledge we want to update in the model. So here's my example where the president of the United States is Donald Trump. It might be something that's generated by a large language model pre-trained up to a certain date, but we might want to update it to be Joe Biden. And so an informal description here of model editing might be, given a small set of edits, these edit statements, usually one, how do we intervene on model weights such that the edit is reflected in the representation space or in particular in the text generated by the model? So hopefully that helps you be on the same page as me when we talk about model editing. Now, I'll just go over a rapid overview of some of the techniques at a very high level, just so when I talk about some of the results, you're at least have a little bit of a picture of how model editing is done. So some of the earlier methods are around some kind of constrained fine-tuning, whether that's only using a few parameters or gradient norm is constrained or something like this to minimize the impact of basically overfitting to this one statement. MEND is another approach where basically we're training hypernetworks to learn to edit a model using gradient information. I think the most probably popular model editing technique in popular imagination is ROME or MEMIT, where basically we're discovering the parameters that contribute to the pre-edit statement, the president is Donald Trump, and we're replacing those with new parameters that would instantiate the edit statement that we want. And finally, I'll just highlight that people are also using in-context learning, so with in-context knowledge editing, so demonstrating to the model using prompts to show, this is the edit we want to reflect in generated text. So the motivation for this paper really comes from how we evaluate techniques, because it's important to understand what the impact of these different interventions are, and as a community, as we build model editing interventions, how do we know what one's better than the other? Typically, we have these short evaluations where we have some edits. So here, our edit statement is the Eiffel Tower is in Rome, and we evaluate it using a prompt and then look at the next token or a small number of tokens afterwards, the completion. And so we ask a number of questions like, was the edit actually made? Is the edit now reflected in the post-edited model? And so we could prompt the model with the Eiffel Tower is in, and we would expect the completion to be Rome. Similarly, we can ask about generalization of the edit. So if we have a paraphrase of that prompt, we would expect, again, the completion to be Rome. We also have these kind of unique properties where we want to understand the impact of the edit in the model at large. So we want it so the Champ de Mars is a landmark that's near the Eiffel Tower, and locality of the edit really means we want to make sure things that shouldn't indeed change. So the Champ de Mars shouldn't move to Rome. That's not something we expect. And similarly, there are things when we say when we make a factual edit where the Eiffel Tower is now in Rome, we expect things like the restaurants around Eiffel Tower, when prompting the large language model, to be the restaurants from Rome and not the restaurants from Paris. And that's typically called portability. One of the things that we noticed when using these model editing techniques is we really don't have a good set of evaluations for understanding whether the edit is reflected in long form generation, paragraph length generation. So when we have model editing techniques that do quite well at short evaluations, when we just look at the next token or the next few tokens, but here's sort of a toy example you can see just to illustrate the problem. If you use more tokens for generation, you might get these degenerate generations where, oh, actually the Eiffel Tower is, when we talk about it, it's mostly in France still, but we are sort of deceived because the short form evaluation was correct. So this motivated our research question, which is, how would you evaluate long form generation quality after performing a model edit? So we came up with a number of different dimensions that are kind of like extensions to classical short evaluations that are performed for understanding model editing. These are things like edit consistency. So is there evidence the edit was made? Factual consistency, to what extent unrelated factual statements are still true? And some other properties we wanted to ask questions about. The way we did this was we essentially took counterfact and ZSRE, which are popular model editing evaluation data sets, and we constructed prompts where we have one prompt that asks to write an article about the edited statement, including information, properties about that edited statement, such that the completion would be like a long form article. Similarly, in order to measure things like the impact of the model editing on things other than the Eiffel Tower, we have these related entity prompts, which we independently generate passages from to write articles about, a related entity, like in this case, Champ de Mars. And the key thing here is that the properties between the subject and related entity prompt are highly coupled, in the sense that they oftentimes share the same properties. So city, Paris, for instance. So using this coupled entity prompts, we have these generations that we get from a prompting large language model. And this is what we're going to be using for evaluation. So the second thing we needed to do is basically construct instruments in order to have some kind of determination of how humans would evaluate these long form passages. So we have two settings. One is we constructed a survey. It's 9 questions that aligns with, where's my selector? Aligns with these properties of interest that we had. We also had an annotation setting because we wanted to control whether survey and annotation sort of found different or similar findings. And the annotation setting looks very much like natural language inference. Here I can skip to it, where we have a passage. This is our generated passage from, write an article about such and such, and we have a claim. In this case, the claim is ground truth knowledge, or the factual statement that shouldn't change. And we're just asking annotators to determine whether it supports or contradicts that statement. And this is just a view of what the survey looks like. So basically, we operationalize measuring these questions as a Likert scale, 7-point Likert scale. And this is what we do. Now I'm going to skip over sort of some of the human evaluation stuff. We have a lot in the paper, but I do want to highlight one of the main kind of things we wanted to do with the paper was asked, can we construct automatic evaluation methods to assess the impact of model editing on long-form generation quality? So we used the human data that we collected to basically determine whether we could build these automatic methods that had high agreement with the survey taking and with the classification annotations. And so we trained a DiBerta v3 large model for survey rating. Now, our survey sample is quite small. So actually, this is trained on synthetic data from GPT-4, taking the same survey as the humans did. And we got pretty good agreement. This is Krippendorf's alpha of 0.6 across these 9 questions. And similarly for classification, for classification, we just used the human annotation data because we had enough data for that and got a high agreement score there. And so I know this is like a massive table, but I do want to highlight just some of these results. There's sort of a lot more in the paper. This is just to say that we have now this automatic metric that has pretty good agreement with humans taking the survey. So we are allowed to, we now can ask these 9 different questions about model editing, edit consistency, factual consistency, internal consistency, topicality, and naturalness. And similarly, we can use a classifier now. So what I want to highlight here, because I really don't want to go into all of the details of the paper, is what we found was for some methods, like in-context editing or MEND, there's kind of a stability between factual consistency and edit consistency where there isn't too much of a drop-off between edits being reflected in the passage and factual statements that were true before now no longer being true. But for other methods like ROME and MEMIT, there's like a large drop off in factual consistency. And so in this paper, we talk about it as factual drift or, changing too much, these edit methods. And this is something uniquely that we found with, here, I'll skip over this. This is uniquely something that we found with long form evaluation methods where short form evaluation methods really didn't reveal the same kinds of things. So I won't go into this too much, but we didn't really find very high correlations between short and long form evaluations, really only with edit consistency and some of the other properties. And then finally, I just wanted to show some of the qualitative findings that we had. So, and this is kind of what we maybe want to dig into for future work for more fine-grained evaluations of model editing. So there are a number of different kind of categories of problems that model editing introduce in generation. So one of these is disfluency. So we can see, so the edit here is Tony Benn is now edited to be working in Boston. So previously, Tony Benn works in the UK, now working in Boston. And so we can see as a result of the model edit, we have this introduction of disfluency where now it's saying he served as the Boston 1974, 2005 Boston, and so on. And we found many cases of disfluency like this as a result after performing a model edit. Another pattern that we found that was quite interesting was this lexical cohesion issue where the subject of the edit, so in this case, DeLong, where we're making an edit. I'm forgetting what the edit was, but I think it was something about the language he speaks. Now, DeLong sort of slowly degenerates to Deloy and Deloig, and we found this over and over again in different, across different methods for model editing. So there's something interesting here to investigate. I'll just, give one final example about internal contradiction where, we would have these edits where the iPod was developed by Nintendo. And yes, that was reflected in sort of the initial sentence, but then that would shortly be contradicted by the second sentence. So the iPod is developed by Apple. I'm not sure like how much time I had. I may have gone over technically, but maybe I can like stop for questions and go back to slides if people had things that I could that I missed. But that's essentially our paper. And you can contact me here if you have questions about it or ask here.
What's the best way for me to ask?
You can ask it and I'll translate it to him.
Okay.
Yeah, you have to come closer.
Okay, yeah. So I'll be asking you.
Okay, fine.
Right, yeah. So this is sort of relevant to the DeLong example. So I was wondering, there's no guarantee as the editing side effect only happens to nearby or similar concepts. There might be some chances that after you edit the Eiffel Tower is in Rome, then tomato becomes gray.
Right.
Yeah, so I was just wondering if you have looked into these things. It's probably just relevant to the lexical cohesion, but
no, it's a really important. I think it's like a big concern. I didn't sort of mention it, but it's a big concern with model editing in particular. So there are a few. There's a benchmark for evaluating this. I think there are a few more now, but one's called ripple edit, where basically we have this concept of a neighborhood of related entities, and we can go sort of a few degrees out and determine the impact. So at least people are looking at that kind of thing. But in terms of, whether making a change like DeLong now speaks ASL changes tomatoes are green, like that's something I'm not sure how you would evaluate. I mean, there is this concept of locality that I mentioned before in short form evaluations, where there is this stability around the neighborhood of the subject that we try to ensure. But yeah, going many degrees out is not something I think people discuss. And I think it's important for model editing. It's just very, very hard, I think, to think of evaluation methods to do this.
We want to go up and...
Hi, great talk. I was just wondering how edits that are plausible in the real world, such as changing who the president of the US is, which does factually change every 4 to 8 years, versus something like changing who developed the iPod Touch, which is sort of a historical fact that will never change, if that has any effect on the results you're observing here.
So that's a good question. I think people tend to, there was this early decision kind of made in model editing literature that we would look at counterfactual edits that are kind of implausible, because if you could make a large language model do like edit according to a counterfactual statement or a hard to edit statement, then you've done model editing, right? You've created an intervention that works. We did look at this. So we looked at we constructed sort of an inverted version of ZSRE that's used for model editing, where we had this edits where the previous factual knowledge that was generated by the large language model was untrue. And we corrected those. And these were things that were, plausible corrections, right? And we do notice that so this is like, I don't know how clearly you can see these slides, but this is for factual correction down below here. And it turns out that in factual correction below, for editing, models tend to do better. There are some differences, like for MEND on GPT-J, it's not as good, and for fine-tuning on Llama 2, it's not as great. But yeah, there are these small changes in the score that make it better. But when we sort of look at our main results, there wasn't a statistically significant difference in whether you're looking at like factual correction task or counterfactual correction task in the overall generation quality of models. One thing I will say that is kind of a surprising finding is that for factual correction, or maybe there's a reason why this is, but for factual correction task in model editing, it's actually much harder to have consistent, like for the ground truth the ground truth statements that were previously true to be no longer contradicted. So in other words, it's like as if the large language model, now you sort of updated this, the president is Joe Biden, the surrounding facts that should change, that they don't change, right? It's almost like the large language model stubborn in the facts that were that were true before. And so factual correction is in some ways harder than counterfactual updates for reflecting in these sort of a wider scope changes. I hope that answers your question.
Yes. Thank you.
Thanks, everybody.